Well, excellent. So we are going to start today with this class on space exploration. And I have, we have studied about the moon and the different planets, and we talk about orbits and how things are, moving in space. Again, I want to encourage you to participate in the chat if it is relating to the class. Okay. Okay. And if you have comments outside of the class, okay, you can carry those in the chat, but privately. All right, or after the class, you can also do that way. Okay. So if you also have questions, you can participate on the microphone if there's not a lot of background noise. Okay. So let's talk now about space exploration and the moon landings. So this picture is no more proposals, okay, of marriage or anything like that. All right, I don't think that is the intent of the class. All right. So this picture is the first satellite that was put in orbit. Okay. And the Russians, the Soviet Union, actually launched this in an elliptical low orbit around the Earth on the 4th of October 1957. All right. And this first satellite, Sputnik, it was, really it was a sensation. So this was 23 inches in diameter. So what about, this big in diameter, okay? Not very big. And it was just a sphere with antennas that would transmit pings. Okay, this wasn't space junk, and none of these things are really space junk. Some they are actually very, very useful. The term space junk is actually referred to some leftovers from rockets or things like that, satellites that are still in orbit but are not being used. Okay, so there is some space junk. But any satellite that is still is in use and around is not junk. It's actually being used for a good purpose and mission. Sputnik is no longer in orbit. It fell, all right, like most things. It is so it is no longer in use, and the mission of Sputnik was actually to see could we put something in orbit around, okay, and it would transmit beeps. So let me see if I have the the little, okay. Okay, hold on a second. Well, it was transmitting just radio beeps, okay, that people could actually listen. You could tune in on the radio, okay, and listen to Sputnik, and it would just go beep, 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 beep in different modulation of the beeps, and that would encode information about the temperature and about the amount of electric charge in the atmosphere and so on. It was a very important thing, and it was the first time that something was orbiting on space. I've seen that you could actually see it, if it was a very, very clear and dark night, you could probably see the Sputnik, okay, but it is not very big at all. This was the first US satellite, all right, Luna first, and it was a satellite around the moon, so this was now put in orbit around the moon. Okay, in order to prepare things for the lunar missions. So then we have in the 1960s, we have that the Apollo program started. I would like to see if we let's see if we can listen to this little animation here of the moon mission. Okay, now I'm going to take the speakers. Let's see if this would work okay for you guys. Okay, let me know in the chat if you can hear the sound.
We choose to go to the moon in this decade and do the other things, not because they are easy, but because they are hard. Because that goal will serve to organize and measure the best of our energies and skills. Because that challenge is one that we're willing to accept, one we are unwilling to postpone, and one we intend to win.
All engine running. Liftoff. We have a liftoff.
So this is an animation
The hour. Liftoff on Apollo 11.
Work, the different stages. The first person that we heard speaking was the President John F. Kennedy. So the Apollo rocket had different stages, like 5 different parts to it. So you see that the first stage was in charge of orbiting the Earth and then going out into space. This was going really, really fast. Everything was moving. Now you have the command module taking the lunar module out. As they orbited the moon, the lunar module separated, and that is what descended down to the moon. 2 astronauts were in the lunar module, and 1 remained in the command module orbiting the moon, going around the moon.
Tranquility Base here. The Eagle has landed.
So the lunar module landed, and again, only 2 of the astronauts were able to walk on the moon.
That's one small step for man, one giant leap for mankind.
So after doing all the collection of things, they would have to go back. Part of the lunar module remained on the moon, and the little part ejected, and then reunited with the command module. Sam is asking the question, wouldn't the flag hang limp? We'll talk about that. So only the top part of the command module was in re-entry. And the splashdown in the Pacific Ocean. Okay. No, it's not. Let's cancel that. Okay, good deal. Thank you. Let me put back the... Okay, can you hear me back? We are going to see if... All right. So Sam was asking a question. Okay. There was a... Okay. So there was a post that said there was a comet and had eerie sound detected from its surface. I haven't seen that, Ben. Okay, so if you can give me some more information on that, that would be great. Okay. What do you mean there, but is that the right number? The last set of numbers only has 3 numbers instead of 4. I don't know what that meant. Some you ask about the flag. Wouldn't the flag hang limp? Right, and then actually I have a picture there of the flag. This was the American flag there on the moon. The flag actually had also a bar here on top, okay, and so it was actually being held on top. The wrinkles on the flag are basically however they put the flag, it would remain that way, okay? So if there was, it wasn't that the flag was waving or moving, there's no wind, there's no air, but also because there's no wind or air to do any movement, everything would remain exactly in the same position forever, okay? So however the astronaut set the flag, if it had any wrinkle, okay, it would stay that way. The same thing with the footprints, okay, of the astronauts, all right? All the footprints would still be there today. There's no atmosphere, no wind, nothing to erode the surface. And that is one of the reasons why we can see the craters in the moon, even though they may have happened, you know, thousands and thousands of years ago. The craters are exactly the same way of when they happen, when the dust settles, it settles and there's nothing to move it there, okay? So yeah, unless it gets hit by another meteor and then it creates another crater, all right? So that is why we see that there are craters that go one on top of the other, okay? So, but yeah, so excellent questions, very, very good questions about this. Oh, let me go back to this part, all right? So we have that the Saturn V rocket was composed of several parts, okay? So there were 3 main propulsion stages, okay? So you have the first stage here, the big one. This is the largest of the stages. Actually, it's up to here, okay, of the Saturn V, up to the middle. All right, let me get the pen, and so I mark. So this was the first stage. This was the stage that provided most of the thrust, okay, for the liftoff. All right. So imagine that at the very beginning, going from 0 and leaving the atmosphere, that is when you have to provide the most thrust in order to escape the gravitational pull of the Earth, all right? And also it's because you are, you know, still here on the ground at 0 speed. You're not going anywhere. So this stage was basically all fuel, and the main propulsion that you saw there at liftoff was all provided by the fuel in this first stage. So that is stage 1. The second stage, okay, stage 2, is this part, okay, this part of the rocket up to here, actually, all right? And that was also for propulsion but that was now to take the rocket and put it into orbit around the Earth. Okay, so let me see if I go back to here, to this picture of the whole trajectory. So it started here in Florida, and so the first stage was to get out of the atmosphere. The second stage, and it burned just, for a few minutes, actually, because all that fuel was burned, really, really fast to provide all the thrust in order to take the whole rocket out of the atmosphere. The second stage was used here for this part, all right, and it provided the thrust needed to put the rocket around the atmosphere of the Earth, around in the orbit of the Earth. This picture is actually not completely accurate because the rocket actually went 1.5 times around before it went out. Okay, so the picture is not completely accurate. Yes, so it went 1.5 times before it went to the moon. Now, why did it need that second stage to provide all that thrust? Why did it go around? Jens asked a question, so that is the question that I want to ask you. Why did it need to go around? Do you remember momentum? Excellent, yes, so that is the answer. The rocket really needed to gain speed, okay? Do you remember when we were talking, let me see if I can find it really fast, the presentation, okay, let me see, the presentation where we did Newton's experiment, okay, I think that is this one. Okay, yes. Do you remember this one where we talk about the cannonball experiment? Okay, and how things actually stay in orbit. What was it that you needed for something to actually stay in orbit? So we have here the C is a circular orbit, okay, or D an elliptical orbit. What did you need in order for something to stay in that orbit? Yeah, momentum or movement. You needed a lot of speed, and that is what that second stage provided, was in order to gain enough speed, okay, to get into orbit around the Earth. Because imagine the first stage was to escape the Earth's atmosphere, okay, and then it put the rocket kind of in an orbital trajectory, but then it needed still to gain a lot more speed in order not to fall back, because if you went out of the atmosphere but then you didn't reach enough speed, it will fall, okay, and so what we wanted was to stay out there. And so that is what it needed. What kind of fuel did the rocket use? I know that it was a mix between some sort of solid fuel and liquid oxygen. Okay, so let's. Could you find out while I'm here? Sam, okay, or anyone else, okay, for that matter, you can go to Google and try to find out, search for fuel for Saturn V rocket, okay, and let's see what you can find out. If you find out something, let me know, and if you have a microphone, you can tell us and everything. Actually, if you want, you can even show, or you can send me the link of what you find, okay? All right, so the second stage was actually used for that, okay? Oh, no, cancel that. Ooh, I keep doing the same thing. That is scary. So the second stage was used for that. Okay, let's go back to the presentation mode so we can see this better. Okay, here we have an answer. The Saturn V rocket's first stage carries 203,400 gallons of kerosene fuel. Oh, wow. And kerosene fuel and 318,000 gallons of liquid oxygen needed for combustion. At liftoff, the stage's 5 F-1 rocket engines ignite and produce 7.5 million pounds of thrust. Okay, wow, that is amazing, really. That is impressive. So kerosene. I know that in the Space Shuttle, the fuel tanks actually are solid fuel. So I don't know what is the type of solid fuel that they use. Could you also please Google that? So Google the fuel for the Space Shuttle rocket. Okay, and those thrusters. All right. Typing this. Yeah. So can you can probably you don't need to do it in the private chat, Sam. Okay, just do it in the public. Okay, so yeah, so do it in the public chat. Let me see if I can copy what Sam found. All right. Yeah. So this is what Sam actually found. So yeah, so stage 2 was basically to give this propulsion to put the rocket out in orbit, and then stage 3 provided another extra thrust to reach and surpass the escape velocity. Okay. Yeah, click where it says all entire audience instead of sending it to the private. Okay. So yeah, everyone, if it's something related to the class, guys, you don't need to chat privately. Send it to everyone in the class. Okay. If it's just a question for me about not the class, then it's probably best to do it after the class, or you can do it privately to each other. But if it's about the class, do it to everyone, so everyone can also receive this. Okay, excellent. Thank you guys for your participation and for looking these things up. I was saying that the rocket engines for the space shuttle are actually built here in Utah. Okay, so the company is Thiokol. Okay, and it's a local company that actually is the one that produces those the thrusters, you know, the two tubes on the sides of the space shuttle that actually provide all the main thrust for the putting the rocket out in orbit. Okay, where in Utah? I think that is in Roy, so it's in northern Utah, north of Ogden. Okay. And every year, I think that they do some test or something like that, and they launch, you know, on the ground. They don't launch it up, but they launch it here. They burn one of those tubes, you know, for a test. When did Apollo 11 take off? It took off on June 20th. June 20th is when it arrived, so it was like 4 or 5 days before, so it would have been the 16th of 1969. So my wife was born, okay, right at that time when when men were on the moon. So well, here we are again with the next part of the class. All right. So the fuel of the space shuttle rocket is powder aluminum. Excellent. And it also has oxygen. Okay, why do you need oxygen for all of this? Why do they use liquid oxygen? Okay, so remember that whenever you have a combustion, whenever you have some sort of combustion, you need three things, okay? You need first some sort of fuel, all right, like liquid, kerosene or gasoline, powder aluminum, something like that. And then the second thing is oxygen to burn. And then the third thing is a power source, something that would start the ignition, okay? And once you reach a certain temperature, the combustion would be self-perpetuating, and then you can keep burning the fuel. So you need all those three things. Excellent. And it's interesting to know that these things, the three things, are also the same things that we need in our body to produce energy. Okay? So we need food, we need to breathe, okay? And we also need a spark of energy, really, that is what happens in the cells at the mitochondria level. But it's the same process everywhere, okay? All right. So we left these guys kind of in the middle of this. So we were talking that now we were going to see, let me see okay, oh, this is this one here. Let me see if I can see. Kepler's, okay, in this presentation, the one where we were talking, remember that the trajectory E, okay, was once you have that the thrust of the satellite or whatever is in orbit is bigger, is larger than the escape velocity. So around as long as you have the velocity less than the escape velocity, you are going to stay in orbit. Okay, you could still go in an elliptical orbit, but you are going to stay in orbit. And so the third stage of the rocket was to provide a thrust to go out of orbit into the escape velocity, basically. Okay, and so let's see. So now they went and they did, the translunar trajectory going all the way from the Earth to the Moon. Okay. All right. Okay. Yeah. And then around this part in the middle of the trajectory, they had to do a maneuver that was actually really cool. So the third stage was depleted of fuel, and once that was depleted of fuel, the top of the rocket, that was called the command service module, so all this part, separated from the top of the rocket. Let me see if we go to this part. So this would be the last, so we have, let's go see. So stage 1, stage 2, this was the third stage, okay? And then this opened up, it actually was ejected, these panels on the wall, okay? And then this is the command service module, the tip of the rocket. The astronauts were always pretty much in this top part in the triangular piece of the rocket. So imagine, say, in the little nose here on the top, that is where the command module was, okay? And so in this part, in this little triangle, you had the lunar module inside, okay? And so the maneuver that they had to do was to separate the command service module, both of this part, turn it around and then connect the nose of the command module with a port into the lunar module. All right, so let me see if we go there. Okay, so that is what the maneuver that they had to go, turn that around and be able to lock this in place. Okay, and that way is how they went all the way to the moon. Then when it's very complicated, yeah, it certainly is that way, okay, but this is what was needed, okay. Then this way is how they went most of the time, and then when they enter into orbit around the moon, they had to kind of slow down in order to be captured around an orbit on the moon, okay? Because you didn't want to go so fast that the moon wouldn't catch you, okay? So you had to go at the right speed. Still, it was extremely fast, okay? But you had to go at the right speed in order to go on an orbit around the moon. Then the lunar module separated from the command module, and that is where you saw that only 2 astronauts went down and landed on the moon. Okay. After doing all the exploration, the days that they had there of exploration, then the top part of the command module, of the lunar module, okay, the top part was launched back into space. Now, how much thrust did you need? A lot of thrust to get out of the moon? Remember when we were talking about the amount of thrust that you needed to get out of the Earth, okay, and that the whole first stage was used for that. How much thrust did you need to get out of the moon? Did you need the same amount of thrust? Did you need more? Why not? Yeah, not a lot. That's right. Way less. You still need some. Okay, excellent, Rodrigo. You still needed some because the moon had some gravitational pull, but it's 16 times less, okay? 16 times less of the gravitational pull of the Earth. Okay. Yes, it is really an amazing thing that everything actually works. Okay, it's a miraculous thing how everything worked and how everything had to be calculated and planned beforehand. All right, so all these things had to be carefully planned and calculated in order to make it work. All right, so not only the gravitational pull of the moon is just 1/16th part of the moon, but also all that you needed, all that you needed was just to lift this part out, okay? So you only needed to lift the top part of the lunar module. I think that they call that the Eagle. So before you had to lift the whole rocket, that was, tons and tons of material out into space. Now you only needed to do that. Once the Eagle back was in orbit, it rendezvoused with the command module, with the command and service module. Okay, so then it went back into orbit. It met again with the command service module. It slingshot back around the moon, and then the command module, remember that the command module had also some thrusters, okay? This part, it was the thruster of the command module. Then it also achieved escape velocity to get out of the gravitational pull of the moon and went back to the Earth, all right? Yes, so there was last week actually, there was something really, really interesting. It was a space probe that landed on an asteroid, okay, actually it was a comet, okay. We'll talk about the, comets and asteroids and the different things, what they are, Okay, so it landed in a comet. Okay, I think that is called like G67 or no, G67 or something like that, the name of the comet. Okay, it was also an amazing feat, the first time that something like that had been achieved. All right, so it was a momentous thing, really. Okay, so the trajectory back was also very important, and they had to go again into come back to Earth's orbit and enter the atmosphere at the right angle. Okay, and then the astronauts were just again in the command module in the little tip of the rocket. Everything else was left up there, either in orbit or in space, and that is space junk. Okay, so it had already been used, it wasn't needed anymore, and so it's somewhere floating there in space. And the astronauts landed in the Pacific Ocean, just there in the command module. So see, the whole thing, okay, this whole rocket, okay, that is several, it's like a huge building high. All that was really kind of livable space was this little part at the top. Okay, did the command module go around 1.5 times to land? I'm not sure. I know that they had to enter the atmosphere at the right angle. All right, that is true, Christina, because Annika, sorry, because if they didn't come at the right angle, the command module would be, kind of skipping on the atmosphere and staying in orbit for a lot longer. Okay, so you actually wanted to make it right at the right moment. If you came too steep down, it would fall too fast and then it would burn. Okay, it would heat up too much. If you stay at a shallow angle, it would bounce off the atmosphere and then it would go into space. Not good thing, because there's nothing to catch you. Okay, and so it had to go right at the right angle to come at the right speed. All right, in order to make it in. Yeah, kind of like a bubble type of thing. So an incredible mission, really, something that happened, and it was fabulous. Okay, as part of the lesson, I have for you in the lesson. Okay, let me see if I go there to the lesson. Not that one. Okay, so I have here a link. I link this. Is a documentary about Apollo 13. So Apollo 13, there was, several Apollo missions, and Apollo 13 was one where they had problems, actually. Okay, they didn't make it to the moon, but they went around the moon and then came back. Okay, and this documentary is absolutely fabulous, really. It's one of the things that I just love watching. So I really encourage you to do this documentary. Okay, let me see if I show you in the class. Okay, if we go there to Canvas, log in. We cannot watch the documentary now because it's about 40 minutes long, okay? But it is well worth watching. It is, I have to tell you, it makes me cry almost every single time I watch it. Okay, so it's really, really good. All right, so let's see. Oh, let me go to settings to show you. This is how you would see it. Student view. Okay, so the modules. Yeah, I wish we could watch it here in class, but it is a little too long. All right. But so I have here an introduction about the class. All right, an Apollo 11 video is a very short video. I have here a link to the space exploration article on Wikipedia that talks about all the different missions to different planets, and everything is really, really good, worthwhile reading and studying for you. And then there's two links. This one is a shorter documentary produced by NASA. This one is 28 minutes long, also about Apollo 13. And then this link here is the one that I'm telling you about. For some reason it didn't seem to link correctly, but you can cut and paste this URL there. And that is this documentary that is about 40 minutes long. Okay, awesome documentary on Apollo 13. All right, so so there are three types of missions, of space exploration missions that we have done. Okay, what do you think are the three types of space exploration missions out there? Okay, three different types by which we explore space. Any guesses, ideas? I'll tell you one type. One type is what we have been discussing so far, is what we would call manned expeditions. Okay, so that is one type of expedition, manned expeditions, where actually we are sending people, all right, in the expeditions. So all the Apollo missions, the Gemini missions, the Space Shuttle missions. Okay. Oh, so the question is, what are the types of space exploration missions? Okay, there's the question. What are three types of space exploration missions? How do we explore space? So one of the types are the manned missions that we were talking about. What would be the other two types? Christina, you are right. I don't know what, Spencer, what do you mean by XD? Okay, but Annika, sorry. Probes are another type of space exploration missions where we send robotic probes. Okay, so the robotic probes come in different flavors. Okay, no problem. Yeah. So the robotic probes are, some are like satellites where we put a probe around another object and as a satellite. So we have sent probes around Venus, we have sent probes around Mercury, we have sent probes also around the moon and around some of the satellites in Mars and Mars itself, okay, and so on. There are other probes that don't stay in orbit, that they just go flying by, okay? So that is a second type of probe. Yeah, I know that is almost done. Thank you, Mac. So then the third type of probe is the probe where the probe actually lands on the object, on the planet or the satellite. Last week we landed on a comet, so we had a probe, a robotic probe, land on a comet. And it was really cool because the probe was designed to have a hook to latch onto the comet, and then it had 3 legs, and the probe had screws that would screw itself onto the comet, because the comet was just 2 kilometers wide, okay, in diameter. Okay, it was very irregular shape. It is of a very irregular shape, and so it's so small that doesn't have enough gravitational pull for the probe to stay. Okay, so the probe was the size of a washing machine, Mac. That is right. Okay, so the probe was not very big. Okay, but the satellite, the comet itself, was also not very big. This happened just last week, all right? In fact, I think that it was last Thursday that it happened. You can Google it, and it's really, really an amazing feat, okay? So the probe is actually now, I think that they finally were able to ascertain that it was able to screw. The hook didn't work, okay? So for some reason, they don't know why, but the hook didn't work as planned, but the screws were able to secure the probe onto the comet, okay? One of the problems that I've heard was that the probe has solar panels to provide energy for the probe, okay, to generate energy out of the sun, but it landed in a place that is kind of on an obscure ledge of the comet, so it's not getting enough sunlight, okay? It only gets just like a couple of hours of sunlight, so it's not producing as much energy as they were planning and they are needing, okay? So really, really interesting things, all the different developments of things that are happening in space exploration, okay? Another thing that is important for you to know of space exploration, oh no, sorry, what I was going to say is in the lesson here I have a couple of assignments, okay? One is for you to write a plan, okay, of what it would take to do a manned mission to Mars. What would you need to do for that, okay? The other one would be for you to consider what are some of the things that are impossible that God has done in your life. You know, a lot of people say that was impossible for man to go to the moon, but it actually happened, okay? Yeah, that is. So why would we want a washing machine on a comet, okay? No one can put any clothes in it, you know, to do any washing. So, oh, we forgot the soap. All right, it's just the size of a washing machine. Believe me, it's not a washing machine. Excellent. Okay. All right. So the question is that there are some things that we consider impossible, but God can really provide the way, the means, and the ways to make things possible. Okay, and so I would like to for you to think about that. What are some of the impossible things that God has done in your life? Okay, and write kind of an essay as an assignment about giving thanks to God for the impossible things in your life. Okay, so that would be a good assignment for you to do. All right, so you have as assignment to watch some of the videos here, all the videos that I have in the lesson. Okay, I have also a little introductory video that answers that question about the different types of space exploration. And I hope really that we get back as humanity back into this mode of space exploration. It's actually, you know, kind of sad that we have not come back to the moon. When I was a kid, I remember that every child wanted to become an astronaut. Okay, that was, you know, kind of the coolest thing to be, is to be an astronaut. All right. You know, so now is, I don't know if it's not that talked more about. Okay, there's not a whole lot of talking about that nowadays, but I think that it would be probably the coolest thing to be an astronaut. All right. All right, well, thank you very much. Okay, Annika, you're eating a chocolate pretzel. Okay, thank you for sharing that. I would like to ask someone to give a closing prayer. Okay, so we finish the lesson. So I really want you to think about this learn about the different types of space exploration. What are the things that we are learning from that, and why is it important for us to continue exploring space? Okay, I think that one of those reasons is that for me it makes me feel closer to God, to think and to explore space. It helps me to see the connection with the creations of the universe. Okay, all right, okay, yeah. Everyone is having not having chocolate pretzels, but we are all kind of tasting them, if you wish. Okay. Yeah, don't worry too much. We understand the spelling errors on a chat are very, very common. All right. Ben, do you have a microphone available? Okay. Could you say a closing prayer for us? Would you like to do that? If you can unmute yourself. Okay. And share a prayer with us, that would be awesome. Okay. Go ahead. We can hear you. Amen. Thank you very, very much for the prayer, and thank you everyone for your participation. Thank you for your questions on the chat, and actually also for finding the answers. Okay, and if you have any questions, you can stay in. Annika,